Well, we're back of our second video here talking about properties of the trigonometric functions and the basic graphs. So last one we looked at sine, we're going to look at cosine this time. So if I press this button right here, I will see the graph of the basic cosine graph. Remember we got that from the unit circle over here by looking at the reference triangle, and the blue distance over here is the distance that we're looking for. So as I move this point here, x value, this yellow point, that controls where we spin on the circle. So let me just, I'll tell you what, before I even look at cosine, let's just go back and make sure we understand that. So notice here, if I start at 0, we're in our standard position. So watch what I'm going to do. Watch the yellow point first. I'm going to move it to the right. Now as I do that, as it moves to the right, the corresponding point on the unit circle is spinning. And so here I'm starting at 0. Now I've made it up to pi over 4, pi over 2. There we're at pi, 3 pi over 2, 2 pi. And now what are we doing? As we continue out, this distance here is getting longer. We've already stretched all the way around this circle and then going some more. And so as we continue to move further and further out to the right, we're just continuing to rotate farther and further and further around the circle in the positive direction. On the other hand, as I go to the left, then we're rotating in the negative direction. So start at 0, negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi, negative 3 pi, negative 2 pi. Now we've made it around the circle more than once. Now we've made it around the circle twice at negative 4 pi, and so forth. And so that's going to be the input. Here it's going to be our x value, and we'll see where this vertical line crosses the graph that we're interested in. So here we're interested in the cosine. So the value of the cosine, of course, is the y value on this graph, which is the same as the blue length over here on the unit circle picture. Okay, now let's see, what properties do we see for the cosine graph? Let's take a look here and see some of these properties here for y equals cosine of x. Well, like the sine, many of the things are similar here. The domain is all reals. The range is from negative 1 to 1, and the period is 2 pi. So it starts repeating itself when the unit circle makes a full circle rotation. It's just repeating the same values again. So the period is 2 pi. We see that graphically here on the Cartesian graph that we see here in blue, is because if we shift to the right by 2 pi, we get the same graph over and again, or to the left by 2 pi, or any multiple of 2 pi. So the x-intercepts, let's see where they happen. They happen, let's see, here's one at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2. One way to say that is odd multiples of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative 1 pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so forth. Now, how can you get an odd number? And this is incorrect. Let me fix it. If we put 2 in, that would make it into an even number. And then if we do 2n plus 1, that's going to make it into an odd number, where n is an integer. So now I believe I have what I want to say there. So if you get 2n plus 1, so 2n is an even number, 2n plus 1 is an odd number, and then we multiply by pi over 2, that gives you parentheses 2n plus 1, close parentheses, pi over 2. Those are odd multiples of pi over 2. Those are the x values, and the y values are 0. So those are the x-intercepts, where n is any integer. Just like in the sine wave, these are also the inflection points. This particular one is actually like the sine when when y is positive, the graph is concave down. When y is negative, the graph is concave up. it turns out to have global and local extrema. Basically, the highest it gets is 1, and lowest it gets at -1. Where does it hit 1? Well, it hits it at 0. And by the way, 0, 1 there is the y-intercept. So you can think of this cosine, if you think of starting at 0, then it starts at 1 for y. At this point, 0, 1 right here. And then it comes down as we go to the right here. And this part of the graph here corresponds to acute angles in the picture over here on the unit circle, as you can see. And of course, x's between here and here correspond to obtuse angles, second quadrant. This is third quadrant in the unit circle picture. Of course, the point here is actually in the fourth quadrant on this picture. Okay, so anyway, we have that. Where do the extrema happen? Well, the maximum happens here at 0, 1, but it also happens at 2 pi and 4 pi and 6 pi and 8 pi and -2 pi and -4 pi. So these are even multiples of pi. So that's 2 times n times pi, such that n is an integer for the x, and then the y is 1. The odd multiples of pi, then, are the ones that where the y is -1, and those are where we have the minimum value, which is global and minimum as well. So at 1 pi, 3 pi, next one would be at 5 pi, -1 pi, -3 pi, -5 pi, and so forth. Doesn't have any asymptotes. Okay, now what about symmetry and these identities? Okay, cosine is an even function. Actually, only cosine and secant are even. The rest are odd functions. So if we look over here at the picture and we look at theta and then minus theta, say over here on the unit circle picture, so where we have the same value here and then we have its opposite theta is here, they're on the same vertical line. They have the same x and opposite y's on the left. So the opposite theta gives us the same x on the picture on the left. Well, x is over here on the cosine on the unit circle are actually the y values over here on the cosine graph. So that means we have the same y's here and here. Okay, so if I match the same points, say over here and over here, they're going to have the same y values. Okay, and that's going to happen when they have opposite. One place that's going to happen is if they have opposite x's. So cosine of minus x equals the same as cosine of x. How can we see that on the picture? Well, that means it has symmetry with respect to the y-axis. That if you reflect over the y-axis, you get the same graph. That's what's called an even function. So cosine of the opposite x is the same as cosine x. And one way we can see that it's an even function is by this graph and noticing that it has symmetry about the y-axis. Now what about supplementary angles? So if we go here and then we look at pi minus that, which would be over in here somewhere. Okay, so we're talking about an angle here and over here. If you're looking at the unit circle picture, say here and here somewhere, where they have the same reference angles. Okay, what do we know about those? Well, they would have the same, on the unit circle picture, they have the same y, but opposite x's. Okay, well, we're interested in the cosine, so they have opposite x's. That is the cosine, so that's the y value over here on the right. So the y value, the actual values of the cosines, are opposite when the input is pi minus x versus x. So cosine of pi minus x is the opposite of cosine of x. And so we can kind of see this. If we go a certain distance here and we go that much back from pi here, they're going to have the same absolute value but opposite sign. The one's going to be positive, one's going to be negative. Now what if we do opposite angles, like compared to, let's say, pi over 4, and then so you go pi plus that, would be over here, and in the unit circle, those angles would be pointing exactly in opposite directions. Okay, an extra half circle rotation in the unit circle. Well, those turn out to be an angle pi plus x for one, and the other one's x. Well, they have opposite x's in the unit circle, so that means they have opposite y's over here in the Cartesian graph, and so in fact they are opposites. So cosine of pi plus x is the opposite of cosine of x. And so there we see a summary. Notice that cosine, like sine, is a continuous function, and we also see that they are both waves. Okay? Let me also, while I'm doing cosine, let me go ahead and show you a relationship here, is that they are actually just phase shifts of each other, horizontal shifts. So let me hide a couple things here and just get the graph of sine and cosine. Sine and cosine look very similar to each other. In fact, they're both really the same shape. Now, when are they going to be the same as actually the same value? Well, they're going to be right there and right here in the place where they have the same value. Well, first of all, I have to have the same sign, S-I-G-N, and we know that in the unit circle picture that's going to happen in the first quadrant and the third quadrant. And then for them to have that, they have to have come basically from an isosceles reference triangle, which means the reference angle has to be pi over 4. So these are going to cross each other at pi over 4, and then at 3 pi over 4, and at 2 pi plus pi over 4, and so forth. And so they're going to cross at those places. These, where they cross up here with a positive y, which is 1 over square root of 2. They both have a value of 1 over square root of 2. And that's going to be when we have a reference angle in the unit circle representation that's 45 degrees, or pi over 4 radians. They're going to cross down here with a negative 1 over square root of 2, or negative square root of 2 over 2 for the y value. And that's going to happen when the reference angle is down here in the third quadrant with a reference angle of pi over 4. So that, for example, that might be at, well, right here, what do I have it? I have it at 5 pi over 4, or it could also happen over here at negative 3 pi over 4. Right about there. And so the sine and cosine would have the same value, if I got it exactly where we should go. Okay? The other thing to notice is these are just shifts of each other by, well, one way we could do is take the red graph, which is a sine, and just shift it to the left by, well, how much is this? Well, it's from this line to that one. That's just pi over 2. So if we shift it to the left pi over 2, we get that. I haven't typed this in yet, but so what we're saying, if we shift to the left, that is, we replace x by x minus pi over 2, and that is the same as the cosine of x. Or maybe it's better to think of it the other way around. Take the cosine of x. Yeah, that's fine. We'll just let's do it that way. Okay, so there's a phase shift identity. This is very similar to the cofunction identity. This is negative 1 times pi over 2 minus x. This is the opposite of sine of pi over 2 minus x. And so notice that this is the complementary angle here. We'll come back to that later. So you can see this shift going on. We'll come back and see this relationship between the secant and cosecant as well.